Hello again, and welcome back to question number 6. This time, this is the same question as question number 5, only now we're involving friction. One thing I noticed about the previous video is that there's some lagging. I think my program isn't good enough to kind of make it a nice, smooth video. So if it gets really annoying in terms of lagging, maybe it might be beneficial to turn the audio off and just watch the solution. But anyway, I will try to do my best to make this as quick and painless as possible. So, in this question, we have the same variables. So, box Y, 5 kilograms, box X, 10 kilograms, and a force of 36 newtons south pulling the whole system together. Only this time, boxes are experiencing friction. And the question says that the box that's 5 kilograms here is experiencing friction on Y is 4 newtons. In box X, the friction X is, what was it? 8 newtons. So why is the friction different? Well, friction depends on contact between the box and the surface. Here there's more box, there's more surface to be in contact with, so that's possibly why there's more friction, but we're not getting into that right now. Right now we just need to know that these are the forces of friction that applied to these boxes. So let's begin by doing a free body diagram for each one. Box Y has Fg, Fn, they're equal. It's got the same forces as before. So let me indicate, just like last time. Oops, let's get blue. This time we know that there is a force here, force X on Y, and there's an equal and opposite force here on this box, which is Fy on X, and we know that these are equal and opposite. But they are not necessarily the exact same values as they were before. Now there's other forces to consider, namely the forces of friction. So let's go back to the free body diagram. Free body diagram says that this force pulling the box forward is Fx on Y, and there's friction fighting back, and this force of friction Y is 4 newtons. 4 newtons. So the net force Y is the sum of all forces, so it's Fx on Y plus friction on Y plus Fg and Fn, but they are 0. And we also know, due to Newton's second law, that the net force is the mass of Y times its acceleration, which the last question is the exact same acceleration as the entire system. So let's equate both of these now. Mass of Y is 5 kilograms times the acceleration, and this equals to F on Y plus the force of friction on Y. Now we have to be very careful. We are defining this direction section. I'm going to say we're defining it as positive. So that means the force of friction is 4 newtons in the north direction. So I can write this is 4 newtons north, but I don't want to have to deal with these brackets here. I'm just going to say that I'm just going to say south is positive, north is negative. So I'm going to erase that, and I'm just going to say that this is minus 4 newtons. So again, the net force is equal to Fx on Y plus negative 4 newtons, because it's in the opposite direction from our positive, which we defined as to the right. Okay, we have two variables, acceleration, Fx on Y, and we're stuck. Just like before, this question really is the exact same process. Everything is the exact same as before, you just have another variable. So you have to just be cognizant of that and just be careful. So here we have the normal force on box X, force of gravity, they equalize 36 newtons in the positive direction. Now you have, watch this, this is a key important part here. You have Fy on X pushing it, or pulling it, sorry. I'm just going to, for clarity's sake, so you don't get confused, I'm going to erase this part here. Whoops, erase the notch. Oh, that's a big circle. Hold on. And I'm back. I just want to erase this part here so it doesn't confuse you, so you don't think you're putting the force that's applied on this box here is Fy on X. Now the key thing is that the other force that's being applied in this direction is the force of friction on X. You have two forces here going in that direction, and I don't know which one is bigger, so I just put them, I showed them as kind of relatively the same size for now, but we actually don't know which one is bigger. Force of friction might be a lot bigger, or Fy on X might be a lot bigger. In any case, the net force on X is the sum of all these forces, so it's 36 newtons, positive 36 newtons, plus the force of friction, plus the force from the tension in the cable, which is Fy on X, plus Fg plus Fn, but they will equalize each other, so I won't right now. Also, F net for X is the mass of X times the acceleration of X, which is the acceleration of the system. So equating, I know the mass ma is equal to all this, so m is 10 kilograms times the acceleration, and that equals to 36 newtons, plus force of friction is negative 8 newtons, because it's 8 newtons in the negative direction, plus Fy on X. So, just to be clear, whenever you're calculating X, you always add the forces. This is key. You're always adding the forces. Whether the forces are positive or negative, that'll work itself out later. So, important to note, when you're doing Fnet and you're adding forces, you are always adding forces. Key thing. Afterwards, you'll plug in whether they're positive or negative, and everything will work out for you. So let's simplify this. This is 10 kilograms times N is 36 minus 8 is 28 newtons Fy on X. And now we are in the exact same situation as we were before. We have equations, two variables, and we know that, I'm going to use green for now just for fun, Fx on y is the opposite of Fy on X. So, how should we do this? Fx on y. So I'm going to say, where's my mouse? There it is. So F on y is equal to 5. Okay, I'm going to omit all units for now just so it's faster. So this is 5a, this is plus 4, this is newtons. So the minus 4 went side, so you get 5a plus 4 is Fx on y. Now, Fx on y is equal to negative Fy on X, or negative Fx on y is positive Fy on X. So now I'm going to use this. Oops. Say 10a is equal to 28 plus Fy on X, which is, just confuse myself. Okay, and let's just continue. So we're writing this equation here. So 10a 8 newtons plus Fy on X. So 10a is equal to 28 newtons plus Fy on X, which is, so 10a is 28 plus negative fx on y. So 10a is equal to 28 minus fx on y. Sorry, it's a bit long. 10a is 28 minus fx on y is here. So fx on y is 5a plus 4. So 10 is equal to 28 minus 5a minus 4. So group the a's on this side, so 10 minus, well, plus 5 is going to be 15a. And on this side we have 28 minus 4 is 4. So a, if we had kept the units, we would get this. This is 24 newtons divided by 15 kilograms, which equals to 1.6 meters per second squared. That is the acceleration of the system. Now, smooth sailing from here. Everything is just the same as it was in the previous question. If you find these two forces, you gotta plug in the acceleration into the equation here. So this is 5 times 1.6 plus 4. So 5 times 1.6 plus 4, you will get a force let's continue here. 5 times 1.6 plus 4, you actually get 12 newtons, and the reason I stumbled there is because this is the exact same as question 5. If you are looking for Fy on x, plug 1.6 meters per second into here. Once you do all the math, you get Fy on x is equal to negative newtons. And that's the forces of these are the action and reaction forces between these blocks. So what happened was that even with friction or without friction, these happen to be the same. I didn't know this was going to be the result. I wonder if this is the result in all situations. Maybe not. Maybe it'll take some more investigation. In any case, here are the solutions for number 5 and number 6, and this is how you solve a problem that includes friction. Thank you very much.